Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at how to solve triangles by using the classification of the triangle. Don't forget there are practice problems at the end of this presentation for you to try out in order to demonstrate mastery of the contents of this tutorial. To gain access to our entire course and other valuable learning resources, visit our website at Mathgotserved.com or take a look at the links in the description below. All right, instructions are for us to classify the triangle based on the marking, then find the measure of each side. All right, let's take a look at question number 1. So based on the marking of this triangle, how can we classify this triangle? We have the two sides, AB and BC. They are congruent to each other based on this marking. So let's go ahead and classify it first. So based on this marking, the classification is as follows. A triangle with one pair of congruent sides is known as an isosceles triangle. So this is an isosceles triangle. How do we know it's an isosceles triangle? Since AB is equal to BC. All right. All right. So now we're going to find the measure of each side. So the first equation we're going to go about setting up is AB is equal to BC. All right, since it's an isosceles triangle based on these markings. So the measure of side AB is x plus 1, and that's equal to BC, which is 6x minus 14. All right, so let's solve this result in an algebraic equation. Let's move all the x's to the right side. So we're going to subtract x from both sides of the equation. And then to move the constants or numbers to the left side, we are going to go ahead and add 14 to both sides of the equation. Okay, so add 14. All right, so what we're going to achieve after these two operations is the isolation of the variable x and the number on the other side. Okay, so on the left side, x minus x, that cancels out. On the right side, minus 14 plus 14, that adds up to 0. So on the left side, we're going to have 15 is equal to 6x minus x, 5x. To get x by itself, we divide both sides by 5. That's the inverse of multiplication. And then we're going to have x equals 3. All right. Now that we have that, we can now find the measure of each side. Where you know what AC is. AC is 2. AB is x plus 1. So to find the measure of this, we're just going to substitute 3 into this variable spot right here. 3 plus 1. And 3 plus 1 is 4. So that's AB. And then the last one we need to find is BC. What's the measure of BC? BC is given by the expression 6x minus 14. Now, before we solve this, what do you expect BC to be? Since this is an isosceles triangle and AB is congruent to BC, if AB is 4, we expect BC to be 4 also. Okay, so let's plug in our answer into the expression. 6 times 3 minus 14. And then we're going to use the order of operations to simplify this. Okay, you multiply before you subtract. So you multiply, have 18 minus 14. And your final answer is 4. All right, so there goes the measure of all three sides. Now let's move on to number 2. Let's start off by classifying this triangle. We notice that all three sides are marked with the same number of tick marks, one tick mark namely. So what kind of triangle is this? This is an equilateral triangle because all three sides are the same. Okay, equilateral triangle. Since what? Equilateral triangle. Since AB is equal to BC and that's equal to CA. All right. So let's go ahead and solve this. All we need is a set of equations, just one equation to solve for what x is. So let's just use AB is equal to BC. We could use another pair, but just one pair will suffice for isolating x. All right, so AB is the expression 5x minus 1, and BC is 2x plus 8. So let's go ahead and solve this for x. So what we're going to do, let's subtract 2x from both sides. That will move the variable to the left side of the equation. And then we're going to add 1 to both sides so that the constant 1 moves to the other side of the equation. Okay. If we simplify that, we're going to have minus 1 plus 1, that adds up to 0. 2x minus 2x adds up to 0. So 5x minus 2x is 3x. So we have 3x is equal to 9. And to get x by itself, we're going to divide both sides by 3. Divide by 3. Divide by 3. And then our answer x is equal to 3. Okay? All right, so now let's go ahead and find the measure of all the three sides. Let's start with AB. AB is given by the expression 5x minus 1. So to find the value of AB, we're going to plug in 3 into this expression. So we have 5 times 3 minus 1. Using the order of operations, multiply first. 15 minus 1 is 14. All right, so what we're going to find out is that all the three sides should have the measure of 14 when we substitute the value of x into each expression. Okay, so let's go ahead and test it out to see if our answer is in fact correct. So for BC, we have the expression 2x plus 8. And then when we plug in 3, we have 2 times 3 plus 8. All right, 2 times 3 is 6. 6 plus 8 is 14. All right, excellent. It matches with AB. And then lastly, we have CA. CA is 3x plus 5. All right, we're going to now plug in 3. 3 times 3 plus 5. 3 times 3 is 9. Plus 5 is 14. Excellent. So we can see that all three sides are 14, which basically reflects what the definition of an equilateral triangle is, which is a triangle where all three sides are congruent. All right, let's take a look at question number 3. We're going to start out by carrying out a classification. So how would we classify this triangle? You notice all three sides are marked, just like question number 2. So the classification is, this is an equilateral triangle. All right, a triangle where all three sides are congruent, equilateral triangle. All right, so now let's go ahead and figure out what the measures of each side is. So it's equilateral triangle since AB is equal to BC and is equal to AC. Okay, so we want to start by finding out x just by using the pair of congruent sides. So AB is equal to BC. Okay, so AB is 6x minus 14 and BC is 3x plus 1. All right, so to solve for x here, let's move all the variables to the left side. So subtract 3x from both sides. And then move all the numbers to the right. We add 14 to both sides. All right, so when we combine these, carry out these operations, we're going to have minus 14 plus 14 will add up to 0. 3x minus 3x will add up to 0. So that will give us 6x minus 3x is 3x. 3x equals 15. And then divide both sides by 3. Divide by 3. Divide by 3. And then we have x is equal to 5. All right, so we're going to proceed to determine the measure of each side of this triangle. Let's start with AB. So we should get the same answer for all those sides, right? So AB is the expression 6x minus 14. So let's plug in the answer, which is 5. So 6 times 5 minus 14. Using the order of operations, multiply first. You have 30 minus 14. 30 minus 14. You borrow 1, 10, 6, 2, 1, 1. So 16. Yeah. All right, next one is BC. BC is 3x plus 1. Okay, so plug in 5. So if you have 3 times 5 plus 1. Using the order of operations, 3 times 5 is 15 plus 1. 15 plus 1 is 16. That looks perfect. Remember, this is an equilateral triangle, which means all 3 sides must have the same measure. So everything is looking fine so far. The third side, AC, is 1/5 x plus 15. All right, we plug in 5, so we have 1 over 5 times 5 plus 15. All right, let's simplify this. 5 goes here 1, 5 goes here 1. 1 times 1 over 1 is just 1. 1 plus 15 is 16. So this works perfectly because all 3 sides are the same, which agrees with the classification of this triangle as an equilateral triangle. All right, let's take a look at the last one, problem number 4. So what kind of triangle is this? We notice that only 2 sides are marked. So if only 2 sides are marked, the classification is as follows. A triangle with only one pair of congruent sides is called an isosceles triangle. Okay? Now, how do we know it's isosceles? Since 2 sides AB is equal to BC. Now let's go ahead and solve for x by using this equation AB is equal to BC to set up an equation 2x minus 1 for AB, which is equal to BC x plus 2. Let's go ahead and get x by itself. What we're going to do is subtract x from both sides to move the x on the left to the right, and then add 1 to both sides to move the 1 from the left to the right. Okay, so let's go ahead and carry out that operation. If we do that, we're going to have 2x minus x is x, and then when you notice when you combine 1 and negative 1, that adds up to 0. All right, x minus x adds up to 0. So we have x equals 3. Okay, now with that information, we can find the measure of each side. Let's start with AB. AB is 2x minus 1. All right, when we plug in the value of x, we have 2 times 3 minus 1. Order of operations, 2 times 3 is 6 minus 1, which is 5. Okay, and then BC is x plus 2. All right, carry out the substitution. We have 3 plus 2, which is 5. And that's excellent because these 2 sides are supposed to be congruent based on the fact that this is an isosceles triangle and the markings that we have. And then the third side, AC, is 2/3 x plus 1. Okay, so we're just going to substitute 3 for x. We have 2 over 3 times 3 plus 1. Okay, and then that's going to be, simplify this cancels out. 1, 1. We have 2 plus 1, which is 4. So that's the measure of the third side. All right, so there you have it.